Thank you. My name is Abby Furnish, and I coordinate this monthly seminar series highlighting interesting advances and topics in stock assessment science. And thank you for joining today for our last seminar of 2023. My colleague Bai Lee will take over coordination in 2024 and already has a slate of interesting topics lined up, so we can look for that in the new year. Today, we're happy to welcome Dr. Will Satterthwaite. Dr. Satterthwaite joins us from the Southwest Fisheries Science Center. He works as a research ecologist, and his work focuses on the ecology and life history of salmon. He also serves on the Pacific Council Scientific and Statistical Committee, or SSC. So today's presentation will bring together and look at the nexus of science, modeling, reproducibility, and the provision of management advice. Now with that, I will pass it over to Will.
Great, thank you, Abby, and thanks for the invitation to speak today. I will be talking about a paper recently put out in Fisheries Research. The link is here in the slide, and I believe it's also been added to the chat. As Abby mentioned, I'm a member of the PFMC Scientific and Statistical Committee, and I think some of the ideas in this talk were informed by my experiences there, and also benefited a lot from feedback from other members of that SSC and from US West Coast assessors. But I should be clear, I'm only speaking for myself here, not speaking for the SSC, nor am I speaking on any official position that NOAA has taken. With that, I sort of was inspired to write this paper by thoughts about the reproducibility crisis in science in general, not something that's limited to fisheries, and I think something that's been maybe on the radar a lot longer in fields like medicine and psychology, where basically there's this real concern that a lot of published results in the scientific literature can't be reproduced. And again, we see this across fields, and there's a variety of reasons for this. There are some cases where it seems like it's actually cases of research misconduct or data fabrication. And I would like to hope that in terms of stock assessment, we have enough safeguards that that sort of problem is unlikely. But another big source of the reproducibility crisis in other fields that I think may be affecting stock assessments as well is what's been referred to as sort of researcher degrees of freedom, or maybe more popularly p-hacking. So that's the idea that most of us, I think, learned in our basic science classes about doing tests of statistical significance where a p-value less than, say, 0.05 means there's less than a 5% chance that we could see a pattern in randomly generated data that would be at least as strong as the pattern we saw in the data from our sort of carefully planned and constructed experiment. And there are a variety of reasons why you have to be careful with interpreting p-values. But in particular, even when you meet all the sort of typical assumptions of the statistical models, you really can't interpret the p-value the way you want to if you're engaging in things like multiple testing or what's called hypothesizing after results are known. And there may also be this issue that a lot of journals will only publish statistically significant results. And so we may have a bunch of entirely valid experiments out there that have meaningful results, but that don't get published because they're not statistically significant, which then means if we want to do something like a meta-analysis later on to estimate an average effect size, we're gonna get a biased estimate because we're only publishing the sort of significant results. And like I said, this has been an issue for the larger scientific community for a while, and it's resulted in things like some really attention-grabbing papers or titles like this fairly provocative, "Why Most Published Research Findings Are False." And in this paper, he points out sort of what are some of the scenarios where we're more likely to have these sorts of problems emerge. And among the conditions he highlights are when there are a greater number or lesser pre-selection of tested relationships, when there is greater flexibility in designs, definitions of outcomes, and analytical models, or when there is greater financial interest and when more teams are involved in research. And it seems like a lot of these things are sort of describing the stock assessment process as well. And made me wonder, how much do these sort of concerns apply to the stock assessment process as well? That said, we get these sort of flashy attention-grabbing headlines. There have also been some sort of follow-up papers that try to take a more detailed sort of data forensic look at how big of a problem really are things like p-hacking. And so you have things like this paper by Head et al. That says, yes, we found widespread evidence for p-hacking sort of throughout the scientific literature, but the effects seem to be weak relative to the real effect size being measured. And so, it's an issue, but it's hopefully not drastically altering scientific consensuses drawn from meta-analyses. Similarly, we have this paper by Jaeger et al. That estimated a false positive rate of about 14% in the medical literature, which is higher than the 5% we might naively hope for based on a p-value of 0.05, but is maybe also not quite that kind of sky is falling, you can't trust any published research kind of result. And while p-hacking sort of can carry this implication of it's being done intentionally, I think it's important to realize that in a lot of cases this is sort of something that comes about inadvertently or through the best of intentions. There's this paper by Simmons et al. Where they ask, or they point out, our goal as scientists is not to publish as many articles as we can, but to discover and disseminate truth. But many of us, and this includes the 3 authors of this article, often lose sight of this goal, yielding to the pressure to do whatever is justifiable to compile a set of studies that we can publish. And this is not driven by a willingness to deceive, but by the self-serving interpretation of ambiguity, which enables us to convince ourselves that whichever decisions produce the most publishable outcome must have also been the most appropriate. And so I think it's just sort of a good warning to us to be careful about how we deal with ambiguity and don't sort of fall into sort of post hoc convincing ourselves that whatever gives the sort of most desirable result must be what was appropriate. And so then that leads me to ask, so what are our goals as stock assessors or as reviewers of stock assessments and or as managers who are in charge of putting assessment advice into practice? And so it seems to me that akin to the pressure on academic scientists to publish significant results, I think there are incentives on both managers and assessors to sort of be thinking about the political implications of, or the result-based application of science products. And I'll give some examples, and a lot of this will be inspired by my time with the Pacific Fishery Management Council, and in particular around its groundfish stock assessment process. That said, I can point to examples in other fishery management plans in the PFMC as well. How some survey outliers are treated in some coastal pelagic species assessments, and how the sort of monitoring of rare events with low detection probability are handled in salmon fisheries or in highly migratory species fisheries, where sort of people were pretty happy to apply ratio estimators whenever no events were observed. But once they started observing events and getting estimates of very large numbers of these undesirable events, then there was a strong push to do something a little bit more sophisticated. But I'll focus on groundfish, largely just because of the large number of assessments and a sort of reproducible process for how assessments get scheduled and reviewed. I'm most familiar with the Pacific Fishery Management Council in the US West Coast. I suspect similar processes occur in other areas. To the extent I'm drawing examples from the PFMC, it's not that I'm trying to single out the PFMC as being worse or sort of more concern than other regions. It's the one that I know best. So to give a little bit of context to the system I'm describing, so the Pacific Fishery Management Council manages, I think, something like 70, although I could be off, it could be even more, stocks of groundfish, which is way more stocks than we can assess each year or sort of each 2-year management cycle. And so as a result, we have to go through a process each cycle to select which stocks are we going to assess. Then a stock assessment team develops a model, usually a base model that they then present to a stock assessment review panel. That stock assessment review panel will surely request a lot of sensitivity analyses, and in the vast majority of cases will actually make some requests for changes that make it into the final model. That final model will then be reviewed by the SSC, and assuming approval of all these previous steps, it will be adopted by the council to inform management. In some cases, we'll hold what's called a mop-up panel, where if an assessment isn't quite ready to get the full endorsement in one of these earlier stages, but there's sort of a clear path forward, we think, to get it to that stage, it can sort of be sent to one additional meeting for a little bit of further review before it's sort of finalized and adopted. And because we have way more stocks to assess than we have assessors, That means we have to prioritize assessments, and that means if we redo an assessment for a particular stock, that means leaving another stock unassessed. Partly to try to increase throughput, there's been an increased adoption of what we call sort of data moderate approaches, which typically include fewer data types than our sort of fullest or benchmark assessments. But that said, even these data moderate assessments, which may, for example, lack a fishery independent survey index of abundance, are still generally pretty data rich compared to a lot of assessments done in other regions. And then once we have assessments, just briefly how we use them. One important output from an assessment is an estimate of status or depletion, so the sort of current biomass relative to the unfished biomass. And then really critical for catch advice is the overfishing limit, or OFL. And we assume there's some true but unknown value to this overfishing limit, which is the maximum amount we can catch without overfishing. And associated with that OFL, we specify a sigma to measure our scientific uncertainty. Sigma is supposed to be the sort of standard deviation of a log scale, log normal distribution describing the ratio between the true but unknown OFL and the OFL coming out of the assessment. The combination of OFL and sigma allows us to determine an acceptable biological catch, or ABC, which is reduced from the OFL to account for scientific uncertainty. And we do this in a way based on a sort of council policy decision of P star, which is ideally speaking the probability that the ABC that is chosen is greater than the true but unknown OFL. So to illustrate that graphically, we do an assessment that estimates what is the exploitable biomass. We come up with an estimate of the sort of fishing mortality rate corresponding to MSY. And then our OFL is just the product of that FMSY times the exploitable biomass. And just note to file away for later, if we think the current biomass is well above the biomass at MSY, that means the OFL in the near term may actually be higher than the long-term MSY. We're focusing on not having an unacceptably high rate, which may lead to a high amount of catch in the near term when you have a stock that's well above the MSY. Once we've had that OFL, we establish an ABC by multiplying that OFL by a buffer. So again, the OFL is the maximum amount that can be caught without resulting in biological overfishing. The ABC is reduced from the OFL to account for scientific uncertainty. I won't really talk about, there are ACL, annual catch limits, and ACTs, annual catch targets, which can be no larger than the ABC. These are really used for sort of management considerations around things like sector-specific allocations or uncertainty in the implementation of regulations. They may also be lowered relative to the ABC for ecological, economic, or social reasons. But I'll really focus on just how we get from the OFL to the ABC. And so the idea again is we assume that there's some log normal distribution across all assessments that describes what's the ratio between the true but unknown OFL and the OFL coming out of our assessment. We assume that the median of that distribution on the log scale is 0, corresponding to a ratio of 1. And then we assume that there's sigma describes the spread of this log normal distribution around that. We then choose a P star probability that the ABC we choose will be larger than the true OFL. And we determine a buffer by finding this Z value where the area under this curve integrates to P star. And then we determine the buffer by exponentiating Z basically. So the buffer is just, again, what do we multiply the OFL by to get the ABC? With that in mind, I sort of asked the question, what are we trying to achieve in fisheries, or at least what should the scientists involved in the fisheries management process be delivering advice on? Now, you might think we're trying to deliver advice on how do we harvest exactly the correct single species MSY for every species in our FMP. I think that might be, an interesting goal for an ideal world, but probably not something we can achieve in reality, both due to the uncertainty in our individual assessments and also probably ecosystem considerations and trophic interactions that would prevent that being even sort of biologically possible. But I think also it's not realistic to think we can prevent all cases of biological overfishing. Again, because of our uncertain assessments, certainly in some cases, we probably will specify OFLs that are too high. In some cases, we'll probably specify OFLs that are too low. And unless we take an exceedingly precautionary approach, there's really no way to be confident we'll never have biological overfishing occurring. I think a great long-term goal would be to achieve multi-species optimum yield, but we'd have to sort of come up with some shared definition of what optimum yield is, and then we'd have to somehow know how to achieve that optimum yield. So I think realistically, what I think, scientists, at least in the US West Coast, we're sort of tasked with how do we provide scientific advice that comes as close as possible to delivering a system where there's a p-star probability that harvesting the ABC for any given stock would result in biological overfishing. And the PFMC generally uses a p-star of 0.45. It sometimes uses a p-star of 0.40 in cases of sort of heightened concern or precaution. It has considered, but never to date used, p-star of 0.35. I'm aware of other regions using buffers that are sort of more conservative and might sort of correspond to a lower p-star if done in the same framework. And as I mentioned, there are issues that the ACL, may be lower than the ABC. We may, in many cases, not actually attain the full ABC. And I think these are sort of real issues for managers to grapple with, but I think they're sort of separate from how should we be specifying ABCs relative to OFLs. I also, again, will acknowledge, I think, there's a scientific portion of the assessment process, and it does fit into a larger process where, political concerns and social concerns are taken into account. And, I think there are other parts of the management system where those sort of processes are addressed. There's sort of other parties other than the assessment scientists and reviewers, so I think it's sort of their job to be addressing those aspects of the problem. So given that sort of my take on the system of what scientists should be doing, some of the areas I think bias might creep in include how we assess which stocks to assess or not to assess in any given cycle, what standards of proof we use when reviewing an assessment, calls to revise assessments before they're adopted, or redoing assessments or adding competing assessments to the mix sort of ahead of the normal schedule for assessing. And I'll go through sort of a couple examples or potential examples of each of these. First, in terms of stock assessment prioritization. So here I've borrowed a slide shown by the Northwest Center of the PFMC on just one of the many aspects that goes into this sort of spreadsheet used to score priorities for assessing different stocks. And basically just see there's a score, the lowest possible score is given to a stock that was recently assessed to be at a biomass well above MSY. And the highest priority is given to a stock that was recently assessed to be below the minimum stock size threshold and to be declining. And I can see the sort of intuitive appeal of this kind of system. But actually, I think you might argue, well, if we know or if we think that a stock is a very low abundance and we think it's declining, maybe actually our top priority doesn't need to be reassessing that stock right away. Maybe we really need to just be thinking, what will happen if we reduce fishing pressure on that stock for a little bit and see how it responds? Similarly, I don't know if really our absolute lowest priority should go to stocks assessed to be at high abundance, because again, we're setting the OFL to be well above long-term MSY for those sorts of stocks. And so we may want to be cautious about locking in that really high OFL just based on one assessment that's at high biomass. And it also sort of concerns me if you look at the 6-point sort of intermediate score that's for a stock whose sort of spawning biomass is unknown, so it has never been assessed, and it has a sort of vulnerability score, which is based on this analysis of productivity and susceptibility that's high. So we're sort of saying a stock with unknown status that is low productivity and highly susceptible to the fishery, that's actually sort of a moderate priority to reassess or to assess for the first time, whereas a stock assessed to be at low abundance and declining is our highest priority to reassess. And I'm actually not sure that's the best way to be approaching this. There's also definitely been calls for sort of different standards of proof depending on the stock status coming out of an assessment. So here is a flowchart that was initially developed by the PFMC in 2013 about how should it deal with these sort of data moderate assessments. And the proposal was you would do a data moderate assessment, you would review it, and then depending on the output of that assessment, if the assessment said that the stock was above the BMSY reference point, then we would report the status as the assessment estimated. And there's a step here that says the SSC should assess whether or not there's enough data to do a full assessment But whether the answer to that is yes or no doesn't really matter. It's just sort of a low priority candidate for a future assessment. If the data moderate assessment passes review but comes back with a sort of precautionary zone result, so it's not in the zone that says overfished, but it is in the zone below its biomass target, then again, we report that status, but then we assess whether there's enough data to do a full assessment. And if so, it's an elevated priority for a full assessment soon. If not, it's sort of treated like the sort of high status assessment. And then the proposal was if the assessment came back below the minimum stock size threshold or estimate or saying that a stock did meet this criteria for overfished, that then the SSC should ask, well, could we have been doing a full assessment instead? And if so, we should actually not adopt that assessment right now. We should do the full assessment and then base our sort of long-term response to what that full assessment turned out. But only if it was not possible to do a full assessment would we adopt that assessment, even though it had been approved by the SSC. And as I mentioned, this was sort of originally a motion made to the PFMC in March 2013. There's a little bit of murkiness about whether the council ever formally adopted this process. It has sort of resurfaced lately, but this never made it into the FMP as sort of an official approach. And the SSC for the Pacific Fishery Management Council did recently go on record saying, like, yes, data moderate assessments can be used for status determination, full stop. There was another sort of similar flowchart shown to the SSC. This one, I'm not going to walk through in detail. It was again sort of, it was a little bit less, it was a little bit more consistent in how it treated different types of assessments, but it still sort of would give sort of an extra step to double check before really adopting a data moderate assessment that said a stock was overfished, whereas it would again just happily accept an assessment that said the stock was in good status. And then, what really inspired me to write this paper was a few things that happened during the 2021 groundfish assessment cycle with requests to sort of redo or re-review some assessments. So in June of 2021, the SSC looked at, I think, about 11 total assessments where I'm going to be a little bit vague in exactly, well, they turns out they were not for 11 different stocks as formally defined, but they were for sort of 11 different combinations of species by areas. And out of those 11 assessments, all of which were endorsed by the SSC, the PFMC pulled out 5 of them saying, let's take another look at these. And 4 of those 5 were data moderate assessments. In September of 2021, the SSC took a second look at all 5 of those assessments and re-endorsed all 5 of them, but the PFMC decided to send 4 of them for yet another round of re-review. Meanwhile, there were some assessments done for lingcod in 2 areas that indicated good status, and those assessments were adopted without any sort of delay, even though they came up with sort of kind of contrasting sort of pictures of the biology of the stock in the 2 different areas. Much higher natural mortality in the north than in the south, higher steepness or stock recruit relationship steepness in the north and in the south. And there was even a statement in the stock assessment review panel report saying an overarching conclusion by both the stock assessment team and the STAR panel is that neither model is capturing key aspects of the population dynamics. So, some real concern there on the science side, but sort of happily adopted because it said good status. In November of 2021, actually, the SSC did suggest changing one of those 5 assessments. It actually was the one full assessment among that group, and it sort of was reconsidering the catchability applied to the fishery independent survey in that one assessment. The SSC reaffirmed its endorsement of the remaining assessments, although at that point in time it was sort of determined that the FMP actually didn't really clearly define what the stocks were for these species with multi-area assessments. And so in some cases, areas were combined, so there were fewer total units, and that led to fewer sort of defined stocks that were actually below the overfish threshold. And the SSC, made a note that, ideally we would have been defining these stock boundaries ahead of time, but hindsight being 2020. And so, that cycle wrapped up in November 2021. In June 2022, the council started prioritizing for the next cycle. It prioritized reassessing one of the species copper rockfish, and if possible, only in those areas where its status was assessed to be low. Meanwhile, lingcod was really not even part of the discussion of what to assess in the next 2 cycles, despite that sort of biologically implausible assessment. And then there was discussion of the idea of, well, maybe there should be a process sort of checking in along the development of a stock assessment, and potentially be the ability to pull the plug or stop developing an assessment if it seemed to be headed in a sort of, not necessarily just that it was headed towards poor status, but just if the data weren't coming together the way people initially anticipated, there was a proposal to just be able to pull the plug rather than send it to the SSE or STAR panel, which, certainly the SSE or STAR panel could say, no, this assessment doesn't pass muster. But the idea was maybe there should be a way to sort of pull the plug and not even get to that review stage. And then some very recent developments in 2023 assessments. So indeed, copper rockfish was reassessed in just 2 out of the 4 total areas originally assessed in. In that particular case, the new results of the full assessment were actually very similar to the previous data moderate assessment. And then the one sort of species coming out of this where the area that sort of met the criteria for overfished was recognized as individual stock. The council still has sort of not fully adopted the assessment or corresponding rebuilding plan for that stock, and has in fact made a request to the SSC to review an alternative assessment for that stock developed by some outside scientists. Don't yet have anything to report about how that went or what exactly the scope of that review was. That's sort of scheduled to take place in January. And then meanwhile, there was a sort of limited update assessment of sablefish to incorporate some recent signs of strong recruitment, which, it seemed like it was a fairly straightforward assessment, pretty consistent with how the previous assessment was done, but it is sort of something a little bit unusual in the process to sort of adopt something with the sort of amount of review that had, and being something, a sort of approach to assessments that we'd never really used before. And so this made me think, there certainly could be opportunities for something akin to p-hacking to be happening here. And so hopefully, I think it goes without saying that if we're just, taking favorable or high status assessments and accepting them, and just sort of rejecting or having revisions done to low status assessments, I think we can sort of all agree that will introduce bias in the process. But I think there's something more subtle we need to think about too, which is that even if we might have reasons to think that some assessments are more reliable than others, we still need to be really careful about how we approach this. I think we need to be, cognizant again that managers face pressures and incentives that they're going to respond to. When I raised this concern to the SSC, we actually got a comment from a voting council member who was attending the meeting, and he sort of said, from the perspective of a manager and a council member, it's logical to expect that we'll pay more attention to these more pessimistic assessments. This is consistent with the need to instill confidence for managers and stakeholders that the results are robust. And from a management or political side, I can clearly see where this person is coming from, but I think we need to think about what might the statistical implications of that sort of approach to things be. And have to acknowledge, assessors and reviewers may also have their own sets of pressures and incentives they're responding to. They may or may not operate in the same direction as the sort of pressures and incentives that council members face. But it just makes me think we really need to be careful not to fall into traps of sort of post hoc reasoning. And I think we really need to be really careful about sort of making directed requests to include new data types or to do different analyses if we're really just making those requests with the expectation that will push the results in a particular direction. And so far, this has all been sort of very qualitative expressions of concern, but nothing quantitative. When I first raised this issue with the SSC, I wanted to provide first a sort of a very simple straw man quantitative model, but just to make this point that even if we're actually good at identifying which assessments are less reliable, if we're only pulling out the unreliable assessments we think are too pessimistic, we may actually be introducing an FMP-wide bias, even if we're actually improving those individual assessments that we're taking another look at. So I first developed a sort of very simple straw person model. where I said, let's suppose we start out with a set of median unbiased category 1 assessments. So category 1 is just PFMC jargon for sort of the most data-rich assessments. And we typically assume those sorts of assessments are median unbiased. And we assume the sigma, or again, the log scale standard deviation, the ratio between true and assessed OFLs, we assume for that type of assessment, sigma is 0.5. So if we start out with a set of assessed category 1 assessments, on the log scale, we have this nice symmetric normal distribution of the ratio between true and assessed OFLs. That corresponds to a log normal arithmetic scale distribution where we have a median ratio of 1. So on median, the true and assessed OFL are equal. And if we want to only have a 45% chance of overfishing, we pick the 45th quantile of that distribution, which corresponds to a buffer of 0.94. Now let's suppose that we are very skillful at identifying which assessments are better than others. And let's say we identify the 20% of assessments that are making the worst underestimation in the OFL. And so let's pull those out for now. And so what was our nice, beautiful symmetric log normal distribution is no longer symmetric. It no longer has a median of 1. It has now a long tail on the left. It has a median of negative 0.13, corresponding to actually now the median true OFL is only 88% of the assessed OFL, but this is before we've added in those redone assessments. If we assume that when we redo the assessments, we do that in an unbiased fashion, and again with a sigma of 0.5, then what we end up with in the end is this sort of distribution that's skewed. It's got a median that's negative on the log scale, that's less than 1 on the arithmetic scale. And the 45th percentile, which before was at 0.94, is now at 0.85. And so what that means is, once we've done this, our median assessment now actually yields an OFL that's about 11% higher than the true OFL. Or our standard P-star of 0.45 buffer of a 0.94 multiplier, that's about 10% too high. And so if we apply that buffer, or if we apply the standard buffer of 0.94, we get an ABC that's actually on median 5% higher than the true OFL. So that's as if, we think we're having this risk-averse P-star of 0.45, but it's really as if we were picking a P-star of 0.54. So it's actually the opposite of risk-averse. Now, certainly I'll acknowledge, this first pass model was overly simplistic in many ways. It's probably, well, first of all, it was totally arbitrary on my part to say, let's look at reassessing 20% of assessments. Although that's not actually totally out of line with, in 2021, we had 11 assessments going in, and ultimately one of them was changed, 2 were redone, and then there's this third, it's sort of nebulous. We've been asked to look at a competing assessment for it this January. It is certainly the case that suspiciously high assessment results may get extra scrutiny too. It was pointed out to me the Pacific Ocean perch in 2017. I think this was probably more at the SSC or star panel review stage, but it certainly got, the sort of initial base model was just sort of viewed as implausibly high in its estimate, but this does seem to be less common. And then, a big problem I think with my initial strong person model was that there could well be sort of shared effects of either using the same data in the assessment and the redone assessment, or just if the same assessor is doing the initial and revised assessment, there's going to be some component of the error in the assessment that's going to be retained from one assessment to the next. Still, I think we can just sort of, for statistical reasons, expect some sort of reversion towards the median or mean. I think there may well be requests for either adding data or making particular structural changes in the assessment that people think are likely to push the results in a particular direction. And then also, I think there's the risk that that assessors themselves, they may want to get off this treadmill of having their work reviewed and reviewed and reviewed again, and so they may either consciously or subconsciously make model choices they hope will make the sort of revised model more palatable to either the reviewers or the managers who are sending their assessments back for re-review. And so I developed a new model that tried to incorporate some of these additional considerations. So I said, well, what if we model a process, what if we model the error in assessments as sort of the product of 2 different processes where there's, it's still sort of log normal error, but it's a function of 2 different sources of error. One is sort of things, again, that are intrinsic to the assessment, like data that's going to be reused in any sort of plausible assessment, maybe assumptions that just are shared across all sort of plausible candidate models. And if it's the same assessor, then there might be persistent assessor effects. And then there are choices in structuring any individual assessment, including sort of which data sets to include or exclude, how to weight different data sources, which parameters to estimate versus fix, choice of priors, things like that. And that's sort of an assessment-specific source of error that if it's redone, that part of the error could change. And so I simulated a set of assessments. Well, I said, well, if I want to preserve that sigma of 0.5 overall, then I can just sort of use the equation for sum of variances to break down the assessment-specific and the intrinsic proportions of this variance. And then I'll simulate a whole bunch of assessments where I draw the assessment-specific or the stock intrinsic error only once, and then I'll draw the assessment-specific error once for the first pass for all assessments, and then I'll draw that again just for the subset of stocks I simulate being reassessed. I looked at a variety of scenarios with different combinations of intrinsic and assessment-specific error that all added up to that same sigma total. I will note the way we came up with our overall sigma is sort of based on a meta-analysis of different assessments applied to the same stock over time. So I think we could argue that most of the error, at least that we're capturing in our current sigma, really is the assessment-specific rather than intrinsic part. But I did look at a whole range of how these things play out. And then I modeled different scenarios where either we picked assessments for extra scrutiny at random, or we picked them in an informed but not directional way. So we just picked out the worst assessments regardless of which direction error was. Or I simulated where we were informed in how we picked out assessments. We picked out the worst assessments, but only the worst assessments that were unduly constraining. We didn't worry about the worst assessments that were overly optimistic. And then I looked at what happens when we look at different proportions of assessments being subjected to extra scrutiny. So again, start out with, before we redo any assessments, we have this nice symmetric distribution of the ratio between the true and assessed OFL, median of 1, and buffer of 0.94 to get our 45% probability of overfishing. If we just randomly select assessments to redo, then the distribution does not change, sort of reassuringly. If we redo some assessments with the largest errors, but we do this in a symmetric way, then we still have a median at 1, we still have a symmetric distribution, but it's now sort of skinnier than a log normal distribution. So the median is still 1, sigma has gone down from 0.5 to 0.4, and these multipliers for the buffers have gotten a little bit closer to 1, but they haven't really changed much. You contrast that with if we pick out assessments that are overly pessimistic and redo them, now our distribution is not symmetric anymore. The median now is less than 1. Sigma actually doesn't change by much. And then the multipliers we need for different probabilities of overfishing have become smaller. And so I made a bunch of graphs like this, where on the x-axis, I looked at what proportion of the variance is specific to the assessment versus intrinsic to the stock. So over on the left, that's saying that most of the error is due to assessment-specific factors. Over on the right, it's saying that most of the error is sort of intrinsic to the stock and the sort of unchanging data. And on the y-axis, what fraction of assessments are redone. And then here, these contours are what's the median ratio between the true OFL and the assessed OFL. And so you can see sort of the more assessments we redo and the more that the error is assessment specific, sort of the smaller this multiplier gets, or the more bias we're introducing. And if say most of the variance is specific to assessments, then if we redo more than about 10% of the assessments, we actually have on median an amount of bias that is larger than our default p-star 0.45 buffer. So potentially, if we redo too many assessments, we're actually what we think is a precautionary buffer is actually not precautionary and not even risk neutral. It's actually prone to overfishing if we're redoing a lot of assessments and if most of that error is assessment specific. Can also look at how the sort of appropriate buffer changes depending on, again, how the variance is distributed between assessment specific and intrinsic factors and the fraction of assessments redone. Again, our sort of default multiplier, if we want a 45% chance of overfishing, should be 0.94. And so we need multipliers that get, several percent smaller than that as we start either redoing a lot of assessments, if a lot of that if a lot of the variance is assessment specific. And if we are redoing enough assessments, then we actually need to get our sort of nominal 0.45 probability of overfishing, we actually need a multiplier even smaller than what we do or what we'd apply in our sort of more conservative p-star 0.4 case. Similarly, if we want to actually achieve a p-star of 0.4, we need even smaller multipliers. Conversely, if we do look at the case of symmetric scrutiny, we can actually use slightly larger multipliers, but notice that the change here between contours, the contours, there's the number of lines is sort of fixed because that's what R wants to do, but the individual contours are only here 0.002 apart. So there's really much less overall change in the sort of required multiplier in this symmetric scrutiny case. And then something that is actually sort of a very helpful reviewer number 2 suggestion on the paper was, well, what if it's actually not the perception that it's not sort of an ahistorical perception that the assessment is too low that draws this call to revisit it? What if what really causes us to revisit assessments is if there's too much of a change relative to the last assessment for that stock? And so here on the left, I'm looking at the case where most of the variance in assessment output is assessment specific. On the right, most of the variance is intrinsic to that stock. And then the x-axis here is actually just sort of how dynamically variable is the stock itself over time. And so if the stock itself is highly variable over time, then being suspicious of large changes is kind of like selecting assessments at random to redo. It doesn't introduce a lot of bias. But if stocks are intrinsically changing very slowly, then sort of by being suspicious of large changes, we are again potentially introducing this bias, similar to the sort of base case. So to sort of wrap up what the potential take-home messages of this modeling are, at least from my perspective. So I think we can say that randomly redoing assessments is in many ways a waste of time and resources. It delays needed new assessments, but it hopefully doesn't introduce any bias to the process. If we skillfully select the least accurate assessments, as long as we do this in a symmetric fashion, it's not going to introduce any bias. And so it might be a good thing, at least in the sense that it's improving those individual assessments. But it's potentially not really giving us much overall of an efficiency benefit or payoff. I mean, we can't actually change our multipliers by very much. It doesn't let us use a buffer that's much smaller. But conversely, if we are skillfully selecting the assessments we redo, but we're skillfully selecting just the ones we think are too pessimistic, then that can give us sort of a FMP-wide bias in our OFLs. And it leads to a scenario where it looks like we should be changing our multipliers by at least a few percent once we start looking at more than about 10% of assessments being revisited. And a few percent here and there, maybe not a huge deal, probably small relative to our unavoidable uncertainty in any of our assessments. But a few percent is comparable to the change that corresponds to the choice of a p-star of 0.40 versus 0.45, which is viewed as a pretty consequential management decision. So I think potentially a bias of a few percent, that's still, I think, a real management consideration we should be thinking about. Also think, in practice, we're not omniscient in picking out which are the worst assessments. We probably have some ability to pick out the less accurate assessments, but I'm sure there's a random element as well. So we're probably somewhere in between truly skillful selection and random selection. So the consequences are probably somewhere between as well. And so, maybe it's not a huge deal if occasionally we redo assessments thought to be problematic. But I think it really needs to be done judiciously. And really, we need to not just single out the assessments we think are too pessimistic. We need to single out, or we need to look at the assessments we think are too optimistic as well. And I think, in terms of how we might address this sort of problem, there's been a lot of attention given to this in the scientific literature generally about, what are solutions to avoid or reduce the effects of p-hacking. So generally, people call for things like have clear a priori hypotheses, have a restricted set of candidate covariates for your analyses ahead of time, be transparent in your, sort of model selection and statistical significance criteria. There've been a lot of calls for pre-registration. So before you write the paper, before you even see the results, say, here's what my experimental design is going to be, here's what my sample size is going to be, here's going to be my statistical test, and here's how I'll interpret the output of that statistical test. If people do multiple tests, there are things like the Bonferroni correction you can do to adjust your p-value accordingly. And there's also been calls to adopt a more stringent significance standard than p-value of 0.05, especially for novel findings. And I think similarly in the stock assessment process, there may be parallels to each of these. I think it's wise if we can select the stocks to assess, if we set the boundaries of stocks, if we sort of set the scope of what data can be included, if we set what best practices are in terms of assumptions and fixed parameters and things like that, and set review standards in advance before we've seen the output of any specific assessment. I think we need to focus on what's the scientific support for an assessment, not what are the management implications of the numeric output of that assessment. I think it's a very bad idea to have a sort of option to pull the plug on an assessment that looks like it's headed in an unfavorable direction. Again, there's always the chance for the star panel or SSE to say, like, no, the final product just doesn't pass mustard, but I think pulling the plug is a dangerous idea. I think potentially, if we are going to be revisiting some assessments, then maybe we need to be revisiting either our choice of P-star or how we specify sigma so that we can sort of come closer to preserving the nominal probabilities of overfishing. And I think we need to have stringent standards for what are the criteria under which we could redo or revise an assessment. And towards that last point, looking around at how different regions work, I see, for example, the New England Fishery Management Council seems to have a very specific, very restricted set of criteria under which it will, the sort of New England SFC will reconsider an ABC specification. Similarly, there's this paper by Scott Crossan from 2013 surveying how different SFCs work. And he points out the Mid-Atlantic has sort of a similar policy. I would also say, Scott, if you're listening, well, anybody, if you're listening and you're interested in sort of how the review process and SFCs and councils interact, I think this paper is very interesting, really did a lot to inform me. And I think, Scott, there could be a lot of value in sort of a updated revisiting of sort of how have things changed between 2013 and 2023. If you'd had any interest in that, let me know. I think we might want to take another look at these ideas. But some other next steps I've been thinking about are, is there value in doing sort of a literature review on what factors predict which sort of assessments get remanded or redone, or even sort of intermediate outcomes like being sent to mop-up? Is it worth sort of taking the same sort of modeling framework and looking at the probability that the actual realized catch, rather than just the specified ABC, which we may not actually catch, exceeds the true OFL? Maybe what we really need to worry about is just whether the realized catch is exceeding the OFL more often than we think or want it to. I've also wondered, could we do something similar to these analyses, but looking not at the OFL specification, but looking at estimates of status or depletion? There, I've been wondering, can we just sort of assume that the ratio between true and assessed depletion is also going to be log normally distributed? What should sigma be for that? I'm not sort of aware of any kind of meta-analysis on that. Maybe sigma and depletion status might be larger than sigma and just current biomass due to additional error in estimating the unfished biomass. But maybe it would be smaller because we might have correlated errors in how we estimate both current biomass and the unfished biomass. Or maybe sigma will be similar if these factors sort of cancel each other out. Another thing I've been wondering is, can we look at the distribution of assessed statuses in a way that's sort of similar to P-curve analyses that have been done to look at instances of P-hacking in the scientific literature more broadly? I.e., not to say, like, would we be suspicious if there seemed to be a lot of status assessments piling up either right around the target biomass and or just above the overfish threshold? But conversely, maybe that's actually exactly the kind of distribution of statuses we would expect to see in a management system that's working well. We would expect that we're driving most stocks towards their target biomass, and we might hope that sort of, we're doing a good job of detecting when stocks are getting low in status, and so we're doing a good job of keeping them from crossing that overfish threshold. So I'm not really sure what we could actually learn from that sort of broad scale look at, the distribution of depletion estimates. That said, I would, these were sort of things I was thinking about kind of on my own independently. And then it was pointed out to me, there's actually this great paper by B et al. On Fish and Fisheries that doesn't tackle these in exactly this way I was thinking of, but I think it does have a lot to say that I think is relevant to a lot of these points. With that, I would like to thank you all for your attention. And it looks like we do have a little bit of time available, so I'd be happy to take any questions or discussion people would like to have. I guess all the questions will sort of get routed through the moderators, but I'd be happy to take any questions they read me.
Thank you so much for your presentation, Will. Audience, we do have time for questions, about 9 minutes, so please put them into the questions chat box and I will read them to Will. And while we're waiting for your questions to come in, I encourage you to download Will's slides, which are chock full of information and DOIs to great articles. So the slides are available under the handouts menu, and I encourage you to do that immediately before we log out. You may also want to click on the link in the chat box for NOAA Central Library's YouTube channel so that you can access the recording and share it with others who could not join us today. Again, that should be showing up right now in your chat. So we did get a question in the middle of your presentation. I'm going to go ahead and start with that. This first question asks, systematic reviews seem like a logical way to address some of the issues related to bias, p-hacking, and synthesis. Has the FSC or NOAA stock assessment community thought about applying evidence synthesis methodologies?
That's a great question. To my knowledge, no, and I'd actually be interested in sort of any kind of links or papers on either just sort of the details of that approach or examples of where it had been used in other systems. But to my knowledge, no, that isn't something that has come up.
Thank you. This next question says, great talk. Large recruitment events are rare, but strongly impact dynamics and can cause significant bycatch issues. If big recruitment triggers reassessment, example, sablefish in 2023, that can lead to bias, but what's a better alternative?
Yeah, great question. And again, I don't know that I would say, the sablefish is necessarily an example of something that would trigger bias, although I think it could trigger bias if we sort of are, if we're more likely to reassess something due to evidence of a really strong recruitment event, whereas we might have evidence actually of a really weak recruitment event, and that might actually cause some people to say, well, let's not reassess the stock to include that information. But yeah, I mean, I definitely I recognize that sort of bycatch issue. I think that's maybe I'll sort of take the easy way out and say that's sort of more of a manager problem. I think there's always a concern in terms of not wanting to unnecessarily constrain the catch of either your target stock, but also, what are sort of the implications of sort of technical interactions. And if you have a low assessment for a particular stock, that may restrict access to another stock. And I think how to deal with that, I think, is an interesting and challenging management question. And I sort of worry that there may have been some scenarios where people are sort of trying to address that allocation problem that comes about from a low status for one stock, not by figuring out how do we deal with these sort of multi-species issues, but just let's see if we can find a way around this constraining assessment for one stock that is sort of constraining our access to another stock. And I think, I don't want to dismiss that concern that, it is a real concern if we're sort of forgoing catch unnecessarily. But I'm just not sure that, redoing assessments is the way we should be addressing that particular challenge.
Thank you. Looks like that might have been our last question. But of course, if anyone has a question, oh, I was wrong. There is another question. This one asks, I would note that conducting an update based on new recruitment information results in less change to the assessment than conducting a completely new assessment.
Yeah, I would agree. I think that's a fair point. Again, especially, at least, in the Pacific region, I mean, there are very specific terms of reference for what can be changed in an update assessment, and that's very limited. It is basically just the addition of new data. You can't be revisiting, sort of various assumptions or choices of parameter specification. So I would agree with that.
Excellent. Well, thank you again for your sharing your work with us today. Well, this was really an interesting presentation.